To understand the concept of variation of pressure with depth, what we are doing, consider this vessel in which we are going to place a liquid. Okay, let's say liquid is filled up to this much level. All right, so this vessel is filled with liquid and our whole orientation is towards finding the pressure inside the liquid. All right, so see what we are doing. We are considering, first of all, let me draw the liquid completely. Okay, so now we are considering two imaginary points inside the liquid. Let's say point this and this, let it be P and Q, and between these 2 points we are again considering or imagining a cylindrical shaped vessel, or not just vessel, it's just a liquid column of cylindrical shape. All right, so this is my liquid column of cylindrical shape. Done. Now this surface which was at point P and Q, now liquid, according to the previous theory, liquid is going to exert force or pressure on this liquid column, right? So this is a liquid column, the imaginary liquid column inside our given liquid. Now it's right. So this is how I am drawing forces. Let us say this is force F1, and F1 will be equal to pressure on the surface P1 times area. The force will be upward in this side, it will be, let us say, F2. So this is an upward force which is acting on this surface, and I am considering F2 is equal to P2 times A. If the P1 and P2 might be different for different heights or different depths, so let us say this is the height H between these two surfaces. So we have considered the surface area of cross section to be A, the depth or the height between these two surfaces be H, and F1 and F2 be forces acting on this thing. Okay, what would be the mass of this imaginary liquid column? The mass is considered as, the density is what? Mass per unit volume. That means mass is equal to density into volume. So density times volume. Density times, what is volume? Area of cross section into length. So area of cross section into height H. This would be the mass of this liquid column. Now, since when we just leave a liquid a liquid filled in this container like this, we are not going to see any type of movement in the liquid, right? Because liquid is in stationary position. That means the whole thing is in equilibrium condition. That means there is no net force acting on any part of the liquid. So as we have imagined that there is a separate liquid column inside, so if there must be some force acting, there must be some movement inside, but there is no movement. That means this liquid column is stationary. So according to that, all forces sum up to 0. What are the forces? The upward forces are and downward forces are equal. That means downward forces are what? F1 plus weight of the liquid column. Weight vertically downwards, weight would be equal to what? M into G, that is rho A H G, right? This is acceleration due to gravity. This will be equal to downward force, which is F2. So F2 minus F1 or F1 minus F2 will be equal to minus W, or F1 is what? P1A. P1A minus P2A, this is equal to minus times weight, or just bring this term up or multiply both sides by minus 1. P2A minus P1A is equal to W. P2 minus P1 is equal to, what is W? Rho A H G. Rho A H G. This thing gets cancelled out and you are left with P2 minus P1 is equal to H rho G. This is the pressure difference inside the liquid column. Now, what if the P and Q points which we imagine at the beginning, or these two levels, they coincide? That means if H is equal to 0, that means rho H rho G, this will become 0. Therefore, P2 minus P1 will be equal to 0. This gives you that P2 is equal to P1. That means pressure at every point inside the liquid is 0, and also the value of pressure is found out by, now as we have already proved that pressure between any 2 points or any pressure, suppose this is a point, this is a point, this is a point. pressure inside a liquid at any point will be equal. This thing we have already proved. And if you want to find out the value of pressure, pressure can be figured out very easily. We'll ultimately reach this formula only. How? Suppose we have to find pressure for this much height of liquid column. Okay, this complete is H now. So pressure is what? Force upon area. What is force? Mass into gravity, right? F is mg, m into g upon a. What is m? M is volume into density, and rho ah and then multiplied by g. Rho ah times g upon a. So this will cancel out and you will again get rho hg or h rho g. So the things which I have proved from this thing is, first of all, pressure at any 2 point inside a liquid is same irrespective of the fact what the value of other factors are. So pressure depends only on height, density and gravity. Lastly, pressure is equal, and last point, pressure due to liquid column of height h will be equal to h rho g. It will be depending on the height h and density of the liquid g, right? Rho and the acceleration due to gravity g.